the Introduction to SPSS. I'm working on a Mac, you'll likely be working on a Windows, but for the most part things will look the same. In this video we're going to be developing some of the basic statistics and graphs that you're going to be using for the first part of the semester. Now, the data we're going to be using is about the old faithful geyser and how many minutes in between eruptions. So I'm going to be using brand new data. You should be using the data out of the book. But because we're going to be inputting data ourselves, the first dialog that pops up we're not going to worry about. We're going to start right into our data set. Okay? Here you will input your data, all right, whatever it happens to be. In data view, as the rows go down, that's where we put the data, right? Because you guys don't want to sit there and watch me type things in, I have decided to just copy and paste. So this is the eruption time between eruptions in minutes for the Old Faithful geyser. I have 50 data points. The book has 60. You'll notice that at the top there is just some generic name for the variable. If we want to change that, we click over to Variable View, click on the name, and I'm going to choose something that is appropriate for us, so erupt times, something like that, or eruption times. Okay. Go back to data view and we see that the name of our variable has now changed. So now we want to do something with this data. As it is, right, our data is organized by the time that it happens, and that's not a terribly useful organization system for us. So let's do some calculations. So we go up here to the menu bar, Analyze, Descriptive Statistics, and first we want to click on Explore. We want to move the erupt times or eruption times into our dependent list, so which means that it's going to be doing the calculations on that particular set of data. We want to look at a couple of different plots. Our histogram and the stem and leaf are really more interesting for us. You can click on the normality plots with tests. The normality will show up a little later in the semester. You can click that on or not. If you do, you'll get some information on whether or not our data is normal. Okay? Click Continue. And then, because we want to look at some of the other statistics for this data set, click on Statistics. Let's do our descriptives. And confidence interval for mean, this is something that we'll talk about in a couple weeks, where it tries to estimate a 95% confidence for what the average, what the mean time between eruptions is. I like looking at the outliers, and the percentiles is going to be important for our 5-number summary later on. All right, so let's do that. Click OK. All right. So our descriptives are kind of our basic calculations. My mean value was about 94, right? So there's about 94 minutes in between eruptions. The confidence level 91 to 96, so we're 95% confident that the true mean is somewhere between 91 and 96. 5% trimmed, I'm not entirely sure what that means. The median is the median of the data set. We will talk about that a little later. The variance and the standard deviation, these things have to do with how spread out our data is. The minimum is the lowest in the data set, the maximum is the highest in our data set. The range is the distance between these two. There are 49 minutes between the shortest and longest times. The interquartile range is the distance between the 25th percentile and the 75th percentile. Skewness talks about how skewed the data is, and kurtosis, I'm not entirely sure what that means. I'm assuming that the data looks like Kurt Russell. Okay. All right, so our 5-number summary for the data, which we'll talk about in a little bit, is going to be the minimum. The 25th percentile, that's the first quartile. The median, which is the 50th percentile. The third quartile, which is the 75th percentile, and the maximum, which is 110. We're going to see a graph of that a little later. The extreme values I like to have because I like to see whether or not there's a big cluster around the lowest and highest values, right? There's a jump between 61 and 70 on the low end, 110, 108, so that the high end, there's not a lot of difference between them, but at the low end, there's the 61 is a little screwy. Okay. The histogram, right? So this histogram is essentially going to be a graph of our frequency distribution. Sometimes we want to have a little more control over this than the original calculations. Okay? So if you double click on it, you'll come up with something called a chart editor. And here is where we can change some of our properties. If we click on the data itself, we double click on that, we go to binning, we can have some control over where our data starts and the number of bins used. I saw that 61 was my lowest data, so I might want to start my anchor at 60. And if I want my bins to be 5 minutes wide, so 60 to 64, 65 to 69, 70 to 74, etc., I want my interval width to be 5. I hit apply, and that changes the shape of the data set. Okay. If I want to have an interval width of 10, right, so half the number of bars, apply it there, we see that the graph definitely changes shape here. Okay. So this looks kind of skewed to the left, right? There's a big peak and then it kind of trails off. The interval width of 5, there's a little skew to the left here. I think that's my 61. There's nothing in the 65 to 69 class at all. If we want to change this from a frequency graph to a relative frequency graph, right, we can switch the y-axis to a percent. Right, that's going to be a relative frequency graph. Right, 30% of the data would be about here. If we want to add, now watch me not find it. If we want to add our grid lines, that button is up here. Okay, we can have some control over how many ticks we have, right? 20, this is going to be 25, this is going to be 30. If we want to have a little even more control over where our lines are here, minimum 0, maximum 30, I guess that's percent. The data stops at 28, right? If I want to cut this down to, say, 5%, right, that will add some extra lines for us. Right, let's go back to frequency being our y-axis. Okay, and if we want to read our graph, our table off of the graph, which is something that we can do this way, right, we go to scale, major increments, let's go 4. Right, so 0 to 4, so this is 2, 2, 4, 6, 8, 10, 12, 14. So in the 60 to 60, the 60 class, we have 1 data point, 0 data points here, 2 data points in 70 to 74, 75 to 79 as 1, right? There's 14 in the 90 to 94. There is another 14 data points in the 95 to 99. There's 8 data points in the 100 to 104. And so we can actually recreate our chart, our frequency table from this histogram this way. Okay? Right. And if we click off, whatever we finished up, that's going to be the graph that pops up here. The stem and leaf plot, this is a nice way of organizing our data. Our stem, in this case, is going to be the tens of minutes, so there's going to be a 76-minute eruption, there's going to be an 82-minute eruption, 85, 87, 88, 88, 90, 90, 90, 90, 90, 92, etc. So each one of these things on the leaf, each leaf over here, is a single data point. Right? There are 3 that are less than 72 that they just didn't bother sticking on our plot. Okay. Here is our box plot. The top is going to be the maximum. Here is going to be the top quartile, right? So our Q3, our third quartile mark, there's going to be about 25% of the data in here, 25% here. Our median is right here. Our Q1 is this line right here. And if there are dots, these are outliers. Okay? Outliers in a technical sense, we'll talk about what that means later on. Okay. So for the most part, this data is everything we're going to be needing. So what we want to do is we want to export this, file export. I have found that the most, for me, the most useful one is going to be the Word document, because that's going to be the most useful, right? And so I'm going to do Travis A. Olson, Activity 1, Math 220. Right? And I'm going to save that to the desktop, all right, so that I have use for it, so that I can open it up. If you have a flash drive, that's a fantastic thing to use. Okay. Oops. Did it save? No. Oops. Let's try that again. Oh. Duh. Sometimes things don't work the way you expect. Okay, hit OK. Right, that's going to create a Word document that I can then go in and edit. There we go. Right, and it's just going to output the entire sheet that we just had, including the graph. Now this graph is a graphic that I can copy and paste into a different document that I can use. If you want, right, you can use this down here to answer the questions for the problem assigned. Anything that we don't use, in this case, we're not using our box plot. You can delete that. This piece up here, we don't really need that, so that simply tells us what we calculated. Okay. But this allows us access to all of our information that we calculated in a Word document that we can copy and paste, or delete the things we don't use in a report later. Okay. Then to submit this, you would simply go to Canvas and upload your final report, and I'm hoping the reports get better and better as the semester goes on into Canvas. So I hope this helps. If you have any questions, please ask in class, email me, or come to my office hours, or set up an appointment, and we will take care of that. Thank you very much.